Hey, math class. So we're going to move on to our last unit of the year. Can you believe it's here already? So before we get started on the lesson today, we're going to use these examples in the notes. Okay, so go ahead and pause the video here and factor these expressions. Okay, so if you factor these correctly, oh, pen's not working. Hold on. There we go. All right, if you factor these correctly, this first one you're going to look for the factors of -6 that add up to -1, so pretty easy one. It's going to be a -3 and a +2. Second one is going to factor down to the factors of a +16 that add up to a -10. The only way they can happen is if they're both negative. So we're going to use x minus 8 and x minus 2. And for the third one, even though we can probably do it in our head, I'm going to do a factor by grouping, just kind of go over that whole process real quick. So -6x plus 1. So we're going to look for the factors of a times c, which is 5, that add up to a -6. So -5 and -1. So we're going to separate this into a -5x and a -1. Bring down my other factors, or sorry, my other terms, and then factor by grouping. So factor out the GCF on the left, leaving an x minus 1. And the only way to get an x minus 1 on the right is to factor out a -1. So the two factors would be x minus 1 and a 5x minus 1. Okay, so hopefully that was pretty easy for you at this point after the last unit. So this is actually 7.1. 7.1 is going to be how to solve a quadratic equation by using the zero product property. If you want to shorten down this title, this is what we're focusing on today, the zero product property. How can that help us solve a quadratic equation? So the first question you should probably ask yourself is, what is a quadratic equation? A quadratic equation, or a quadratic polynomial, is when the highest degree is a square. Okay, so those first three examples, those would be quadratic trinomials. And now let's take a look at some real basic stuff that you already know, but is going to apply to what we're doing today. So consider the following here. Let's say we had a number times 0. Okay, what would the result be? Obviously, not a shock to any of you guys. It is 0, right? 3 times 0 would be 0. Anything times 0 is 0. But what if we replaced the 0 with an x value? Would that change our answer at all? No, the only solution that would work for this, if I divided both sides by 3, would be an x equals 0. So we know that, okay, that unknown value has to be a 0. So let's take it one step further. And what if both numbers were variables, like x times y? Well, if x times y equals 0, then we can say that either the x has to be 0 or the y has to be 0. But you could also say that either one or both could be 0, right? So that's kind of the whole foundation to the zero product property. Basically says that if you have a product, two factors, right, a times b, set equal to 0, then either the a is 0, the b is 0, or possibly both. Okay, that's going to help us solve these quadratic equations. So let's take a look at our original expressions. Okay, our original expressions factor down to two binomial factors, just like those. And if we kind of compare these binomial expressions, because they're a product, right, we can count these as an a and a b if we wanted to. Okay, now let's move those from the expression category and let's make it an equation. All right, so all I did was add an equals 0 to make it an equation. And the reason we do this is to set ourselves up to solve for the unknown values that make this true. Remember, the whole concept of solving an equation is figuring out what values make a true statement. Okay, so we're going to take these trinomials, right, our original trinomials. We're going to factor them down to their binomial factors, and then we're going to use the zero product property to solve for those values. All right. So before we get started, I want to talk about the most important thing when we're solving quadratic equations. They're not always going to be nice and lined up like, like these trinomials here. They're not always going to be already in standard form. So that's one of the first things we have to do when we solve these, is to make sure they're in a standard form of a quadratic equation where you have ax squared plus bx plus c equals 0. Everything is to the left. All the terms are to the left, so that all you have on the right is a 0. All right, so now we've got them in their factored form, right? So it's the same expressions we used before. Now they just have a 0, so it's an equation. We're going to use that property of 0, the fact that the zero product property says that if I have two factors multiplied together to equal 0, that must mean one of the factors is equal to 0, right? So we could solve for x just by adding 3 to both sides. And you could easily see if we replace, the x with 3, that would give me 0, which would make this a true statement. But the same could also be true for the other factor. So x plus 2 could be equal to 0. Solving for x here would obviously give us -2. So if I was to replace this one with -2, that would give me a 0 as well. So these would both be true. So now what we have to do is figure out, well, which one of these answers is correct? I have a 3 and a -2. Which one is right? So what we're going to do now is called checking for extraneous solutions, meaning extra solutions or extra answers, okay? So we're going to check to see which one of these is true using the original trinomial of x squared minus x minus 6 equal to 0. So if I was to replace, let's check the first one, 3 squared minus 3 minus 6 equals 0. Well, that's going to give me 9 minus 3 minus 6 equals 0, which obviously is 0 on the left. So 0 equals 0, that is in fact a true statement. So we know that x equals 3 is a true statement, so that's a valid solution. That doesn't automatically, disregard the other equate or the other solution. We need to check that one too. So -2 squared minus a -2 minus 6 equals 0. Is that true? Well, 4 plus 2 minus 6 is in fact 0. So 0 equals 0 again. So guess what? -2 is also a solution. It's a valid answer. So I can just write both solutions separated by a comma, and this just indicates that 3 and -2 are both valid solutions to that quadratic equation. Okay. Now, just to kind of give you a heads up on the ones for today for 7.1, they're all going to be factorable. That's the first thing. Second thing is they're all going to be valid solutions. So we'll talk about more about when we need to really check these answers as we go forward. But for right now, these are all going to have two solutions. All right, so I'm not going to check these other ones. I'm just going to show you, okay, for the second one, so we did the first one. Second one, we're going to set this equal to 0, which you can obviously do it in your head if you want to. It's just going to be plus 2 to both sides. So x equals 2 and x equals 8. So if I was to check both of those solutions, you would get two true statements, no matter which number you used. And again, we'll talk about how this ties into, a function, the graph of the function. It all ties together. All right, so the ones you got to be really careful of is when you have a variable, or sorry, not a variable, a coefficient in front of the variable. The only reason you have to be careful is people make some really simple mistakes when it comes to these. We're still going to solve it like a two-step equation. So add 1, divide by 5, and you're going to get a fraction, which some people might go, well, that looks weird. Maybe I did something wrong. But no, that's totally a legitimate answer. If you plug in a 1/5, you're still going to get a true statement. Same thing for x minus 1. If I set that equal to 0, I get an x equals 1. So the two solutions here would be 1/5 and 1. Okay, those are both valid solutions to that equation. All right, so let's go through the step process, okay? What are you going to do when you see your first equation and it's not in the right order, nothing looks right? Where do you start from, okay? The first step is always going to be to put it in standard form. You're going to follow all your same rules. You're going to add and subtract terms to get everything to the left. Okay, notice all of the stuff is to the left. The reason we want to do that is we want it equal to 0, so I don't want anything on the right-hand side. The second thing you're going to do, and some of you forgot to do this on the test, was to factor out a GCF. Okay, that's going to serve two purposes. The first thing is it's going to make your trinomial smaller and easier to factor. Second thing it's going to do, it's going to eliminate some excess numbers that you don't need to worry about. And I'll show you an example of that in a minute. Okay, after you factor out a GCF, the next step would be to factor the quadratic. You can either do the simple factoring if there's no lead coefficient, or you can do factoring by grouping. Okay, it depends on the situation. Once you have it factored down to your two binomial factors, you're going to apply the zero product property to get your two solutions. Then obviously you should check your answers to make sure they're true. It's a built-in way to check to make sure you did it right. So I definitely recommend you check those answers. But that's basically it. It's a 4-step process, 5 if you include checking it. So let's look at an example. So we have n squared minus n equals 6. And this is going to be kind of a really simple one because it does look like one we just did. But I just wanted to show it to you in a different format. All right, so this obviously is not in standard form yet. I need to move the 6 to the left. So I'm just going to subtract it from both sides. And when I do that, I'm left with a 0 on the right-hand side, which is perfect. Now this is exactly what I want. I have my trinomial in standard form on the left, nothing but a 0 on the right. Okay, I have a lead coefficient of 1, right? So I don't need to do the long drawn-out process. I can just look for the factors of -6 that add up to -1. This is going to be identical to that first example. So n, make sure you're using the right letters here, guys. N minus 3 times n plus 2. Now I'm going to use the zero product property, which says that I'm just going to set the n minus 3 equal to 0, and I'm also going to set n plus 2 equal to 0 to get my two answers. So n equals 3, n equals -2, so my two answers would be 3 and -2, okay? Those are what I consider like a really basic, very simple problem. Let's look at one that's a little more complex, all right? So 4x squared minus 28x equals -48. Again, it's not in standard form, so the first thing I should do is move that -48 to the left by addition. So 4x squared minus 28x plus 48 equals 0. Now, hopefully you recognize and observe that these all have a greatest common factor. So if I divide each one of these terms, including the 0, right, whatever I do to one side of the equation, I have to do it to the other side of the equation. If I divide everything by 4, it's going to make this, this trinomial that much smaller. So what I actually get is 4 times x squared minus 7x plus 12 equals 0. 0 divided by anything is still 0. All right, so we'll talk about what to do with this 4 in a second. But for right now, let's go ahead and factor the x squared minus 7x plus 12, right? So I'm looking for factors of 12 that add up to -7. Hopefully you recognize the patterns by now that in order to get a positive product and a negative sum, when I add them, they both have to be negative, right? So x minus 4 and x minus 3 would do the trick. I'm just going to bring down the 4 from the GCF just to keep it as part of the answer, okay? Now, I'm going to use the zero product property, and this is where you have to recognize that 4 times any of this, 4 is not a possible solution because 4 doesn't equal 0. Okay, so I can kind of just disregard the GCF. That's one of the benefits of making sure you factor out the GCF first. okay? So then I'm going to use my zero product property and set both of these factors equal to 0 using the zero product property. So my two solutions are going to be 4 and 3, okay? Or 4, comma 3. And we could plug those into the original equation here for the x and there for the x, and you'd find that you do in fact get a true statement. You get two true statements, one for 4, one for 3. So they're both valid solutions, okay? All right, so I want to show you two more quick examples that you're probably going to come across on your assignment and on the coformative check today. All right, so let's look at one that requires a little bit of grouping. So 7x squared equals 8 plus 55x. Okay, so first things first, I have to get it into standard form, which means I need to move the 8 and the 55x to the left, right, by subtraction. So 7x squared minus 55x, making sure you keep them in the right order, minus 8 equals 0. Only thing left on the right is a 0. Okay. So obviously there is no GCF, so I can't factor anything out GCF-wise. So I'm going to take the 7, multiply it by negative 8, and I get negative 56. So I'm looking for the factors of negative 56 that add up to negative 55, right? Well, that's a pretty easy one, right? Negative 55 and, negative 56 and positive 1 would do the trick, because that gives me a negative 56 when I multiply. And that means I can separate the negative 55x into a negative 56x and a positive 1x. I'm going to bring down my other two terms, just like before, 7x squared and negative 8, and then separate it by grouping. Factor out a 7x, which would leave me an x minus 8. And the only way to get an x minus 8 on the right would be to factor out a single 1, just 1, right? So now they have a common factor of x minus 8. And once I factor that out, I have a 7x plus 1. And that's still all equal to 0. I didn't write a 0 here, but it's all, the 0 is still there, okay? So now I'm going to use my zero product property and factor out, or sorry, not factor out, set these equal to 0. So this is going to be x equals 8. And then this 7x plus 1 is the one that gets a little weird because it's a two-step equation. So minus 1 divided by 7 is negative 1/7. So my two solutions for this one would be 8 and negative 1/7. Okay? So that's one thing you're going to come across. The other thing you're going to come across on today's assignment is potentially it's already factored or at least partially factored for you, right? So it might look weird. Now I'm going to give you an example. What if it's in function form? You're definitely going to see this on the honors assignment. So if I had f of x equals, let's see, let me get one of the problems from the assignment here. Let's take a look at number 4. Okay, number 4 on the assignment, it's not required because you're only having to do the odds. So I'll do this one as an example. F of x equals x minus 2/9 times x plus 1/2. Okay, so this one's obviously already factored. The problem is we're missing our 0, right? So the nice thing about this function notation is we can just say, well, let's just let this be 0 and figure out what those two 0 products are. Okay, so you can just replace the f of x when you get to these function problems. Just replace the f of x with 0. Because remember, this is like y equals, right? So we're just saying, okay, well, when y is 0, what is x equal to? All right, so let's take this first factor, set it equal to 0, which obviously is real easy to do. You just add 2/9 to both sides. And the second one as well. So subtracting 1/2 from both sides. So my two solutions here would be 2/9 and negative 1/2. So that one didn't require any factoring at all, right? If I look at one that's like number 6 on the assignment, let me clear this out. Okay, number 6, I have f of x equals x times x plus 20, which might look a little weird. And some of you might be tempted to start distributing. Don't do that, okay? We're trying to undo any kind of distribution. So we don't want to distribute right here. We want to just keep it in a factored form. And this is actually an easier proposition for us because we still have our two factors, okay? We're going to say that, well, if x is the 0, then that means that one of our values is just 0, right? If x is 0. The other one is going to be when x plus 20 equals 0. So our other solution would be negative 20. So the two solutions valid for this one would be 0 and negative 20. It's totally okay to have an answer that's 0. That's totally possible. And then one more example I want to show you is, yeah, I'm going to do number 11, even though it's one of the ones you're supposed to do. So I recommend you do the evens. I'm not going to grade them, but do them for practice if you want to. It'd be good practice. But the odds are what your assignment's going to be. So this one is 5x times x plus 2/3, and you can probably figure this out on your own, but I'm going to do it anyway, plus x plus 2/3 equals 0. So this looks a little different, right? It's not in standard form, which is normally our first step. It's an equation, so we don't have it in function form. We don't need to do anything weird like replacing the f of x. But this should look vaguely familiar because it's already kind of set up for you to do factoring by grouping, right? If you separate the two sides, left side and right side, separating by the addition here, then we see that they both have a common factor of x plus 2/3. Right? If I factor that out of both the left and the right side, well, the only thing I have left is a 5x. Right? I can do 5x plus 0, but that's kind of pointless. So now I have it as two factors, which is your whole goal here. We want to get two factors so that we can use that zero product property, setting them equal to 0, and we get our two solutions. So negative 2/3 and 0. Okay, so that's basically it. It should be, if you're feeling comfortable and confident with your factoring ability, these should be very, very simple problems to solve. If not, then we need to go over some things. You need to ask some questions. But that's basically it. You take it, you put it into standard form if necessary. Obviously, 11 didn't require that. Put it into standard form, factor out your GCF, factor the trinomial, or whatever it is you have over there, factor it out, and then set them equal to 0, each factor, and solve for your answers. All right, guys, see you in class.